Hello friends and welcome to Basics of Electricity Part 2. Here we shall analyze a simple circuit and try to measure the voltage and current. Let us consider this basic circuit where battery provides a voltage of 5 volts. There are 3 resistors connected in series of 500 ohms each. Can you measure the total resistance of the circuit? As resistors in series add up, the total resistance of the circuit is 1500 ohms. Can you now calculate the current in the circuit? If you recall Ohm's law, the current is voltage divided by resistance, which is simply 5 volts divided by 1500 ohms, which will give you 3.33 milliamperes. Now in the same circuit, let us take some test points for measuring the voltage. A, B, C, D, E, F and G. We shall use a multimeter to measure the voltage. You may recall that voltage is the measurement of difference in potential at 2 points. If you connect this multimeter across points A and B, since both A and B are at the same potential of 5, the multimeter will show a difference which will be 0 volt. If you now try and connect the multimeter across points A and C, since A is at a potential of 5 and C at a potential of 0, the difference is simply 5 volts and your multimeter shows 5 volts. In the same way, the difference between B and C will be 5 volts. The difference between D and C is 5 volts again. D and E is 5 volts again. So we can summarize that points A, B and D are at the same potential of 5 and C and E are at the same potential of 0. Can you now measure the voltage at point F? To measure the voltage at point F, you will simply place your multimeter leads at point F and C. The multimeter showing a voltage of about 3.33 volts. How did this come? You must always remember that whenever resistors or loads are connected in series, the voltage across them gets divided. Hence, our 5 volt has divided and has now become 3.3 volts. Voltage at F can be given by the simple formula, which is the formula for voltage divider, which is supply voltage into RB divided by RA plus RB. Here RB in the circuit is R2 and R3 in series and RA is R1. So we simply have 3.33 volts. Similarly, voltage at point G is 1.67 volts. To measure the current, you can simply break the circuit, connect your leads and measure the current. To summarize, resistors in series add up, voltage across resistors or loads in series gets divided and the current flowing remains the same. To calculate the divided voltage, you can use this simple formula. When resistors are connected in parallel, the effective resistance of the circuit can be calculated by this simple formula. You can try this yourself. Connect the resistors in parallel as shown in the figure. Take some test points A, B, C, D, E, F, G and H. You can now try and calculate the current and voltage across each of these points A, B, C, D, E, F and G, H. What do you observe? Do let us know.